So, hi, I'm Raphael, and we're going to talk to you about what we've been doing in construction and how we've been trying to make construction smarter. So, there's huge amounts of infrastructure projects today. Some of the largest construction sites we've ever seen are currently being built or about to be built. We're literally building smart cities from scratch. So this is Songdo. Songdo's international business district in South Korea. It's a $40 billion project that spans over 1,500 acres. It's a 10-year development program, and it's one of the most expensive development programs ever undertaken. And the whole city has been built to be smart from scratch. We've got automated waste removal systems. We've got charging stations for electric vehicles. It's literally one of the largest projects ever undertaken, and it's being done right now. So this is the kind of scale of development programs we're seeing today. A bit closer to home, we've got Woodworth. Planning permission for Woodworth was kind of just given last year. And it's one of the largest development programs here with over 30 buildings that are going to be built on the Woodworth area by the Canary Wharf Group. Now, the Canary Wharf Group is running a bunch of programs at the moment, such as the kind of Cognicity Challenge. They want to make Woodworth one of the kind of smartest estates developed so far. But again, massive development program, over 20 acres, and really kind of the plan of making it into like a micro city. A bit different, but still in that kind of same theme, we've got Hinkley Point C. Hinkley Point C is a £16 billion project coming up in October. The plan is it's scheduled to start in October. We're expecting 50 million hours of work to go into that particular project. And it's going to supply 7% of UK energy. It's a nuclear power plant that spans over 175 hectares. So that's, to give you an idea of magnitude, that's over 3 million tons of concrete being poured for just that single construction project. So we've been making our cities smarter. We've been connecting our infrastructure. But we haven't really thought about how we can make the building process smarter. There's been interesting innovation in construction recently, but some of the basic processes have remained pretty much similar for decades. And I guess the latest big kind of, so we've got to move from something like this to something like this. So how do we do that today? Well, at the moment, we've still got a huge amount of manual monitoring. BIM, which is the kind of a building information modeling, has changed a lot of how we do construction. We've seen these kind of digital models that really kind of help with the supply chain. They let all the kind of contractors, subcontractors, the operators in a variety of different fields come together, create a digital model of what your building site is going to look like, and really plan everything well in advance. So that's really good because it allows you to really plan everything out and make sure there's no problem there. But we haven't really been looking at kind of live information and real-time data on construction sites yet. So that's when we started looking at the construction industry, and we said, well, how can IoT help in construction? And you don't really hear IoT construction very often, but we started looking into this, and one of our customers invited us to visit a site and talk to a section engineer, Alex. Now, every day at work, Alex has to check the readings from embedded sensors. He has to look at the temperature of concrete to make sure it's set. He has to look at pressure on retaining walls. He has to look at sound levels for regulatory purposes. He has to look at vibration levels to make sure his building site isn't going to be collapsing. This is really, really tedious for a trained civil engineer and really costly for the project. I mean, Alex has to essentially walk around his construction site, measure things with a handheld monitor, write them down on a clipboard, walk back to his site office, transcribe that into a spreadsheet, start analyzing that data, and he has to do that every single day. So I'll give you a bit of a more in-depth detail, and we're going to talk about concrete temperature monitoring. Sounds fascinating, but actually it is. Concrete takes between 5 and 15 days to cure. It needs to be struck out of its frame once it's set. Now that's really important because if you strike it out of its frame too early, the concrete is going to collapse. Essentially, you're going to have to bring in, I mean, that's a disaster. You're going to have to bring in a whole crew to clean it up. You're going to have to start from scratch. So not only have you created a bunch of debris on your site, you really have to, I mean, you've wasted precious time. If you do it too late, you might have wasted a day or two. It doesn't sound like a lot, but on a project like Hinckley, a 1-day delay can cost you over £1 million. In terms of like all the employees that are on site and especially when you start considering that delays in construction amplify over time. A day at the beginning of a site can really kind of amplify to a few weeks by the end. So really trying to optimize that efficiency right at the beginning is super, super important. So temperature acts as a proxy for the measurement of concrete maturity. You've got a bunch of sensors that are kind of embedded into the concrete, and they provide a profile of temperature. The concrete can kind of go up all the way to kind of 100 degrees Celsius so far, sometimes. And that's, by kind of monitoring that over time, you can tell if your concrete's ready to be struck or not. So, Alex still does all of that manually, and what he really needs is automated real-time monitoring of that kind of data, and that's what we've been doing. So manual monitoring is literally costing the construction industry billions, and that's a massive, massive pain. If you kind of have a quick look at one site, so a site like Hinckley will have about 15 section engineers. Each of them will spend about 2 hours a day monitoring things such as the temperature of concrete. That amounts to at least 100K, if not more, in man-hour costs alone on monitoring environmental variables. That's one site. Right, so what we did is we started working with Lange Rock, one of the largest construction companies in Europe, and we built Converge, which is an end-to-end solution for the whole problem. It's got a hardware node that runs on a low-frequency wireless mesh network. We're talking 868 megahertz to handle the really hostile kind of construction environment. You've essentially got a bunch of mini Faraday cages, lots of steel, lots of concrete. It's not a great environment for wireless networks, which is why we went for low frequencies. That node sends the data back to our hubs, which then finally just sends the data back to our online platform where we can set trigger levels and notify people when concrete is ready to be struck. We've been augmenting existing thermocouples and essentially producing 4 benefits. Kind of a massive saving on man-hour costs, really kind of streamlining the delays and like reducing those delays to significant amounts, allowing companies to easily do quality assurance and kind of look back on the construction side and have a visibility into the site, see how it progresses over time. And then finally, and this is something we're kind of working on at the moment, the ability to bring in external data sources, such as the weather forecast, to be able to kind of optimize how much workforce you have on site to handle the amount of concrete you might be striking every week. So it really lets you have a data-driven approach to the construction process while you're on site. We're currently talking to Lange Rock about implementing our tech on one of their concrete factories. So that's, that kind of factory produces about 1,000 blocks of concrete every week. That's about 5,000 sensors being monitored at any one point in time. And if you could increase the output of that factory by a few percent, you're already making savings in the orders of hundreds of thousands, if not millions of pounds. So this kind of tech will finally allow us to make the kind of development projects that we see possible. There's these huge projects are really, really complex, and connecting and having a more data-driven approach while we build them is really beneficial for the industry. So that's what we do. That's Converge. Thank you.
Thank you very much, Raphael. So sorry about that. So I'm really interested in the Canary Wharf stuff, because we were talking about with the strawberry tree yesterday about opportunities in the Canary Wharf area where they're based. Just tell us a bit more about the project, because I wasn't aware of this Wood Wharf until now?
Yeah, so Woodwharf just got their planning permission this year, and they're going to be building about 30 different massive buildings in an area kind of a bit further than Canary Wharf.
Okay.
And so we're actually on the Cognicity Challenge as well at the moment. Strawberry Tree are as well, I think.
Yes.
And they've really kind of taken in 36 startups, I think, in a variety of different streams.
Really?
To try and help develop the kind of smart city / automated building management and like kind of efficiency and IoT in that kind of area.
That's really exciting, and
yeah.
to have that on our doorstep here as
Yeah.
well
No.
is so the same sort of stuff that you're talking about. Being able to quantify, to contextualize, to get some proper metrics and manage the construction process is what hopefully
yes,
you'll be doing there as well.
That's the hope. We've been speaking to the kind of the guys in charge of all the contractors of the Canary Wharf Group, and they're really interested in trying to make the process of construction itself smarter as well, in addition to just the city. And you know, they've really got that plan of trying to make Canary Wharf into this kind of micro city.
Yep.
And I think that there's a great opportunity there because they own all the land. They can really kind of actually make it happen in a smart way.
And in terms of, you know, you're talking about smarter construction there, and particularly about, you know, concrete temperature management and making sure that it's properly hardened, cured, whatever the term is. Looking at the longer term life cycle of the buildings as well, how do you see that you might be able to fit into that?
So that's a really good point, right? You really, if you want to start having connected buildings and connectivity, you want to do that when you're building, right at the beginning. I mean, we're pretty early on. You know, we're a two-man team right now, but we've definitely considered trying to kind of build in connectivity at the build stage, and that's something we'll be looking at as we kind of progress.
I guess wireless is a good way to do that. You know, you think of buildings that, you know, used to have Cat 5 and Cat 6 going all around the building, but actually everyone's kind of wireless now anyway.
Yeah. So the one challenge there is obviously battery life, because we run on battery, and if you really wanted to kind of instrument a building from the get-go, you'd have to either power it on mains or find some sort of amazing battery technology that could last you 50 years.
Yes. Wireless power.
Well,
bring it on. Any questions for Raphael around the smarter construction stuff? Yes. Hey. Microphone's coming. Wait. Here we go.
Sorry, David. Sorry. Really nice to hear that. It's really interesting what you're doing. I think you're onto something. 2010, SAP Ventures invested in somebody who was just doing the purchasing processes for construction, saving a lot of money in the process and developing the procurement, and it listed for about 450 million. So I think you're in the right zone.
Thank you.
It's really about the savings, and I think one of the things you may want to think about, you made the right decision in terms of spectrum and so on, is could you have them build your system into the building? I think David was hinting at that. There are a number of people working on light bulbs that are also transducers, transponders, right? So you might want to look at that. You can plug them in, take them out when the building's done, put in the lights. Just an idea.
Yeah. So we actually talked to Lang & Rook about potentially, because they've obviously so lighting on a construction site is everywhere.
It's a big deal. Yeah.
So it's the perfect place because it's powered to kind of have your kind of hubs essentially. So we're looking at trying to use that. And yeah, we're looking kind of longer term on what can we do to actually have more connectivity for the whole life cycle of the building. But that's a longer term project. But yeah, cool. Thank you.
And are you going to raise money now, or what are you going to do?
Yeah, we are actually raising a seed round at the moment. So
Don't be shy.
Yeah, no, we're raising a seed round at the moment. So
He's called Joshua. You should go and have a chat with him, all right?
Yeah.
Terrific. Any more questions at all for Raphael? No? Good stuff. In which case, please give Raphael a big round of applause.
Cool.
Thank you very much, my friend.
Thank you.
Good stuff.